Okay, thank you everyone for joining us today for the July edition of the Tri-State Dairy Exchange. This theme for this year is advancing dairy systems through technology. And this month's topic is automation in the barn, Lely's approach to smarter barn management. We have another automation webinar coming up in August, and you can scan the QR code here to register. And our mission with the Tri-State Dairy Team is to advance dairy management, address shared industry challenges, and foster innovation through collaborative educational programs across Northern New England. And the Tri-State Dairy Team is made up of Maine, New Hampshire, and Vermont Extension. And this is our team. We have Dr. Glenda Pereira from the University of Maine. We have Dr. Sarah Allen from the University of New Hampshire, myself, Amber Blodgett, and Kelsey Bram, all from the University of Vermont Extension. And we have a lot of upcoming events this summer. So in Maine, we have the Maine Farmcast with new episodes every Wednesday. On August 16th, there is a pasture walk and cheese tasting in Pittsfield, Maine. And August 20th is actually a collaboration between the University of Maine as well as UVM Extension. And we will be hosting a workshop to take a look at a new dairy sheep mobile parlor in Gardner, Maine. And then over in New Hampshire on August 17th, we have a workshop called Weathering Change, Cover Cropping for New Farmers in Bethlehem, New Hampshire. On September 9th is the New Hampshire Agriculture Professionals Day in Durham. September 17th is the Rotational Grazing and Silvopasture Workshop in Jefferson, New Hampshire. And you can find all of these events listed at the extension website listed there for UNH. And coming up in Vermont on August 13th, we have a mortality composting workshop at Maplewind Farm in Richmond. And September 1st, we're going to continue our Future Ready Dairy series, and that will be at Skyline Holsteins in Derby. And then on September 22nd, we'll have another workshop at Rock Bottom Farm in Stratford. And for our July featured resource, I wanted to highlight some really great videos that have come out about our local Vermont farms. Monument Farms Dairy has put together a really fantastic multi-part series of videos, and you can find those at their website. There's multiple ones. They interview farms from all across the state, and they're just a really great look at our state's agriculture. And then I'd also like to highlight this year's Dairy Farm of the Year winner, which is Livingston Farm. And you can watch their Across the Fence segment at the YouTube channel. And so this month we have Chris Hill from Lely, New England, and he's going to talk about Lely's approach to smarter barn management. So Chris graduated from Cornell University with a BS in animal science and specialized in dairy management and nutrition. Chris spent 8 years as a herd manager on dairies across Vermont. He then returned to school to pursue research focused on cow comfort. He completed a master's thesis on overcrowding with research performed at the Minor Institute in Shazy, New York, and received his master's from University of Vermont. And then Chris spent 8 years working as a nutritionist in the Champlain Valley of Vermont for Pool and Grain. And Chris has now spent close to 12 years with Lely Center New England, consulting with farms across New England and Eastern New York to help determine how automation can fit for them and designing barn layouts to help implement their goals. So with that, I will stop sharing and I will kick it over to Chris.
Okay, thank you. Let's see. Go back here. Thank you, everybody, for taking some time and joining us today. So, just to get started, I'll just do a little bit of an introduction and history of both our dealership and Lely itself, and then we can go through some of the automated tools and solutions we have that might work for you, and look at some of the economics and value of how that could work for you. And then there'll be some time for questions at the end, but feel free to interrupt me at any point if you have a question or idea. So, Lely Center New England, we've been installing robots for quite a while now. The first robots in Vermont were put in 2003 with our owner, Paul Godin, and we've now installed well over 200 robots. That's basically, along with Mueller on the cooling side, pretty much all we do. So we try and keep it lean and do that well. We have 7 service technicians right now working out of our 2 shops, one in our home office in Enosburg Falls, Vermont, and our satellite office in Greenwich, New York. And one of our technicians is actually based out of Connecticut. And for those of you in Maine, we are actively working on getting to Maine as we speak. We know there's a lot of interest there, and we are fully committed and definitely would love to be working in Maine. As of now, out of our 2 shops, we have a technician on call out of both places 24/7. So, if there's a problem, 80% of our calls are solved over the phone. But at the same time, if you need somebody to come to the farm and it's 2 o'clock in the morning on Christmas Eve or something like that, somebody will be there for you. We also have Brianna, our farm management support specialist, along with the technicians on the mechanical side of the equipment. She works with the Horizon software, herd management software, helps farms with their settings and cow access, working with nutritionists to help farms improve their health and performance. And then along with that, we also have our route truck delivery for our entire area. This is our shop in Enosburg. We put this up in 2015, the front part here. And 2 years ago, we added another 6,000 square foot warehouse off the back and our shop in Greenwich, New York. Lely itself was founded in 1948 by 2 brothers who were farming in the Netherlands. And they decided they wanted to help farmers become more efficient for both themselves and their herds. And Lely is actually still a family-run company. Alexander van der Lely is had been the CEO and has now stepped and created a supervisory board. So he's the chair of the supervisory board and still heavily involved with Lely internationally. Lely actually started out as a forage company, forage equipment. Then the first invention was the finger wheel rake. And then they also invented the single disc spreader. And throughout the years, they were very innovative in the field equipment until they decided to look at how not only could they help farmers in the field, but also help farmers in the barn. And along with making the farmers' lives more efficient, make the cows' lives more natural. So in the late 80s, they started working on inventing a milking robot. And in 1992, Lely installed the first milking robot in Europe. Commercially, the A2 model was out for a little while. That evolved through the A3, the A4, and now we're up to the A5. So been continuing to evolve constantly. Even individual robots have subtle updates and changes ongoing all the time. They're becoming more efficient, more reliable, more cost effective, and better for both the farms and the cows. And can you tell this is a Cabot farm if you're looking? So the US still lags Canada and some of the other countries, but we're at but we're gaining. In 2016, 4% of US milk was produced by robots on 1% of dairy farms. And this is based on USDA data that just came out this year. In 2021, that's increased to 6% of US milk and 4% of dairy farms. And I'm confident, if we were able to actually get the data this 5 years later, it would continue to increase. And these results, the highest percentage of adaptation is on farms 150 to 499 head. But along those lines, we've got farms that have converted tie barns into single robot barns. In our dealership, we have a farm with 28 robots, and there are milking 1,400 cows or 1,800 cows, actually, because some are on a satellite farm. And we've got farms across the country with 30 to 40 robots milking 2,000 cows now. And there are plans for ones even bigger than that. But you can see in Canada, about 20% of the dairy farms are robotic. And actually in Western Canada, it's even higher. And in Europe, it depends on the country, but on average, 30% of dairy farms milk with robotic milkers. and some countries like Denmark are as high as 70%. And that's based on, I think, with the quotas they had, higher milk prices along with higher labor. Originally compared to US always running on tight margins and focusing on low cost. I think that's where they've gotten a head start on the automation compared to us. In North America, in the US, Lely has over 4,000 milking robots now, with 120 the mixing of the feeding robots with the automated feed systems. And even though they only came out about 6 or 7 years ago, we're up to 630 manure robots across the US, and those numbers bump up to 8,500 milking robots, 300 vector systems, and 1,400 manure collector robots for cleaning the barn floors. If we expand that, primarily in Canada, there are some others in North America, but primarily Canada along with the US. I can just show you a quick video of how the current milking robot works if people haven't seen this. So the cow walks in the box. She's wearing a collar that identifies her, and it knows exactly who she is. It gives her grain based on her days in milk, lactation, her milk production, and then lasers scan her udder. The brushes clean and disinfect her, and then the lasers will help attach the inflations. And this is all set up. When you're in a parlor, we're looking for about a 90-second stimulation time for good letdown. And if you watch the time at the bottom of this video, if you watched on your own, the attachment time from the prep time is actually almost right on that 90 to 100 seconds or so. And the brushes scrub the teats and also can scrub the bottom of the udder to get any debris or dirt off of the udder. And you can see the lasers flashing on the teats there. So then when she's done, each quarter is milked independently. So the vacuum and pulsation will shut off for that quarter will be removed. And then when the cow's completely done, it'll spray her with a post-spray disinfectant and let her out. So along with labor savings, increased milkings, and some other benefits from the robots, they can give us a lot of data, which we can use to help manage the herd, to increase performance in cow health and save us time and be more efficient. And we can really focus on the cows that need attention versus everybody, like we do when we're milking every single cow in a parlor. I mean, if you could get overwhelmed. So any farm needs to work with our farm's management team, kind of focus on what's going to benefit them. But you can see milk yield, fat, protein, lactose, cell count, all kinds of milk time, color. So there's quite a bit of information to use. And that all gets processed through our Horizon software. So this can be looked at on the main farm computer. It can be looked at, the phone app actually mimics the computer. So, you could be out in the field working, or you could be in Florida on vacation. You can still see what's going on the farm. So this screenshot I actually just took yesterday on one of our customers with 8 robots. They're making about 99 pounds, 98 to 99 pounds of milk. The cows are averaging 2.6 visits a day, a little over 4% fat, 3.3 protein. Refusals means how often cows go in, and it actually hasn't been long enough for them to have enough milk, and the robot will just let them go without doing anything. Free time is kind of an indicator of how much time is available. People always ask, how many cows can a robot handle? And it kind of varies. This free time is a factor. That's how much time is the robot actually down, and not either being washed or used by other cows. So you can see that's kind of red there, 10 to 12% as a minimum is probably a little easier to manage. About rumination activity, there's a lot of stuff you can see just on a glance at the dashboard here. And then this is a herd just to show what some of these are capable of. this farm's making 111 pounds. So this shows you kind of how much milk the robots can process when they're managed well. And the cows are in and out of there in 7.5 minutes, the box time. That's going to kind of drive whether you're going to be at 55 cows per robot or 58 or 62. 8.5 pounds per minute milk speed is very quick, and it's helping this farm achieve these numbers. So along with that, there's a lot of different reports that are we can work with you and to help manage your time and herd. So there are some basic reports, and then we can also customize reports if there's something you're looking for that isn't available immediately. So this is from that last herd with 110 pound average, and a robot efficiency shows how the cows are doing. So you can see like this cow is making 176 pounds, but it's taking her 10 plus minutes in and out of the box. This cow is making 168 pounds, and she's in and out of there in 5.5 minutes. So of course, with that kind of production, that cow is certainly worth keeping. But if you're getting tight for numbers and her production goes down and she's taking 10 minutes to milk compared to these other ones that are under 7 and even under 6, those are going to be some of the factors you're looking at in managing your herd. And you can see her milk speed is only 6.9 minutes versus some of those other ones are pushing 10. One thing with the robots versus a parlor is this herd is averaging 2.8 milkings per day, but cows go in at different times. In a parlor, a cow that's about to dry off is going to go in 2 or 3 times a day. The same as one of these cows making 170 pounds at 60 to 70 days in milk. These cows are actually going in over 4 times a day, these early lactation ones. And then that'll tail off. So they may only go in 1.8 or 2 times when you're about to dry them off. So it allows you to milk the cows that need it the most versus milking everybody the same. Another report is through the activity from the collars predicting heats. So there's a graph that shows a spike in activity, and usually there's also a corresponding decrease in rumination on that graph. And then all that's incorporated along with the ovulation research to not only show that cow is in heat, but also give you an idea when's a good time to breed her. And you can see here where it's yellow to green to yellow, showing optimum insemination time, for the best chance at pregnancy. Another thing that the robots can really help with is predicting sick cows and helping catch sick cows faster than even the best herds person can. It's here between the conductivity and cell count. You can see the conductivity is high at 90. The cell count's pushing 2 million. The temperature of the milk is 103 almost. So without even looking at that cow, we know probably she has mastitis, and we can go out in the pen and check her ahead of time. So along with the milking robots, we also have the vector automated feed system. What this basically is a fancy feed pusher when it's just going along pushing the feed up, but it shoots a laser on the feed and that reads how much feed is left. So rather than having a big massive pile of feed that's going to last 24 hours, it's programmed to only feed when it's needed. So there's always a small amount of feed in front of the cow. So on hot days like this time of year, we drastically reduce the heating and spoilage because the cows can pretty much eat it down and then get refed. So this, if there's enough feed left, it just goes back and charges. If it determines a section is too low, then when it goes back, it's a single screw auger mixer, and it actually mixes up a new load that's, where the nutrition and diets are all programmed into the computer. And the computer all ties in with the robots if you have both. So you can add the dry matter intakes of the group and other information to the data you're getting from the milking robots. So one way of doing this is with a crane, which works well for smaller to medium-sized herds. This crane can go along, pick up you can dump your forages on the ground or have blocks, or if you can use baleage, but it has to be very highly processed to be able to pull it apart. So the crane will grab forages and drop it in the mixer, And then you also can have, you'll have the grain augers, possibly mineral hoppers, water, anything else that's going to be added. And it's all automatically added and mixed. So the crane is very reliable and efficient for, 100 to 200 cows or so. The one downside with it is it's relatively slow, so we run into a capacity issue. So one thing we can do is use live bottom boxes to speed up the feeding. So we have what's called the feed kitchen. So again, you can bring your forages in, except now they can be fed through a conveyor into the mixing robot. So it just accelerates the load time and therefore increases the capacity of the system. And as more of these get out there and working with more larger farms, we've taken it from these stationary boxes where you still would have to bring the feed once a day by buckets to now we actually are. The next step was taking forage boxes, putting electric motors on them so that you can disconnect the wagon, pull it to the bunk, load up a day's worth of corn or a day's worth of haylage like you're seeing here. And then those boxes save time on deliveries without having to bring bucket after bucket and yet still have a fast feed out. And this is a 6 robot barn in Massachusetts, and I'm milking 300 cows, all being fed with the vector system. On the simpler side, just to keep the feed pushed up, where it's always within reach, saving fuel, labor, damage to gates and feed rails, we have the Juno feed pusher. So this just runs, usually programmed to run every hour, and it can run at a distance further out when shortly after feed delivery, and then and run on a distance further closer to the bunk to push the feed in further. And it's using an ultrasound to follow the rail here. And then we use metal strips as reset points at the end of the route and to tuck it in to its charger. So if the feed alley is wide enough, or if it's a single-sided feed alley like this, it can be charged out of the way. But what some farms have done where they have a door they don't need to use, they've actually cut into the scrape alley and made room so it's out of the way and not going to get hit. And you can just see that going along. And the cows usually learn from the beeping, that the feed's getting pushed up. So you often see cows get up and walk towards the feed when the Juno goes by. A more recent development is the manure collector robots. We've had scraping robots that are basically automated squeegees for slatted floors for probably about 15 years. So the next step was to come up with a robot that can clean solid floors. So for 6 or 7 years now, we've had the collector manure robot, which works similar to the Juno in the sense that it bounces an ultrasound signal off to know on pre-programmed routes that our technicians put in. Except the difference is this has a small vacuum negative pressure and can pull the manure into the body of the robot in the tank and actually carry it to a dump in the barn to keep solid floors clean. Like you see here, basically every barn that we have these in looks like this all the time. So some of the benefits are cleaner, drier hooves, cleaner stalls when the hooves are not tracking as much manure in, cleaner tails, and then that can all lead to healthier hooves and potentially less mastitis. And again, a side benefit, in this case, these were new barns. You don't have somebody in the skid steer potentially spinning around and smacking into the headlocks and stalls and beating up the barn. And this is just pictures of the collectors charging. And here's just a short video. So the cows get used to it very quickly. You can see they don't pay very much attention to it. And if it does bump one and doesn't move, all of the automated equipment we have in the barns has a safety on it where if it bumps into something, it'll just stop and you can put it back on track. So it's not going to hurt anything. Another thing we have available for saving time and similar to the milking robots, allowing cows to be milked based on their needs, with higher frequency and earlier lactation and lower frequency and later lactation is the calf feeders. So we can have group housing. The calves, these work off of either RFID tags or collars. So the system knows exactly which calf is in getting a drink and knows how much it can get and how often. So you can ramp it up to a peak, hold the peak, and then have a weaning program. So it's labor saving and also actually using technology to more mimic the natural life of the calves, similar to the way the milking robots mimic, because of the calves drinking more when they're younger and then starting to get weaned, the milking frequency of the cows. And then lastly, we have the cow brushes, which, if you figure out in a pasture in the woods, cows have been scratching on branches and trees. In a barn, they end up scratching on posts and freestalls and things you don't really want them to be bending and wearing out. So these automatic cow brushes usually go over pretty well and they find them very quickly. So it helps keep the cows clean, helps meet their needs for grooming. There was actually a research project done a few years back where the researchers put a brush behind a gate and feed behind another gate that were both tension loaded, and they had the ability to measure the pressure. And the cows actually pushed as hard to go through the gates to get to the brush as they did to get to the feed. So obviously this is all pretty cool stuff. We can, to help with herd health, help save time, make farmers more efficient, but it has to be cost effective to work. So along with that USDA data I showed earlier, there's some new numbers out that show when comparing farms using milking robots to non-adopter farms, the farms with milking robots actually had a 13% net return increase over the non-adopter farms. And then the same information, the robotic dairies had a $3.50 100 per hundredweight higher net return than the non-adopter farms. This was USDA research that just came out in January analyzing precision dairy. Another study showed that farmers on larger farms with 7 robots or more, so basically 400 plus milking cows, reported 21% decreases in labor compared to their previous parlor systems. And then Finbin, which is an analysis put out by the University of Minnesota, when comparing conventional dairies across Minnesota and Wisconsin and some of the other Midwestern states to robotic dairies, found 2.2 million pounds shipped per full-time equivalent versus 1.5 million pounds full-time equivalent for similar size herds, which works out to about a 46% reduction in labor. And if you look at that Finbin data and you narrow it down just to the top 60% of farms for profit, there's about a 51% reduction in labor on the robotic dairy herds versus the conventional herds. I know if you read some of the articles that are out there and talk to some lenders, a lot of people will say that you're not going to save labor if you put robots in. And of course, every situation is different. So that could be true. If you look at a very small family farm where it's all family labor, 2 or 3 family members maybe doing all the labor. If the family members go out 2 hours later in the morning and get to come in an hour sooner at night, or have more flexibility during the week to do other jobs, or even just spend more time with friends and family, usually most family farmers don't record their hours, so that's not going to show up. Another factor is in a lot of farms, they take the labor they had that was doing menial chores like milking, and they have that labor do other things. We've got we have one farm that processes pudding. So by getting rid of their parlor, they not only gave themselves more time to focus on the retail side and increase their pudding sales, they also were able to knock out a wall and increase the size of the processing plant by using the space of the parlor. And then, of course, there's management factors. Like in any business, in any dairy farm, some farms are managed more tightly than others. There are 4 robot farms milking 230 to 240 cows, where if you stop by the barn, there's 2 or 3 people there seemingly all the time. And then there are other farms the same size where if you're not there early in the morning or, late in the afternoon, you're barely ever going to find somebody. Along those lines, particularly where the farms are small enough where the farmers still do a lot of the chores, another study found that farmers reported that their quality of life improves after transitioning automated milking. And one of the biggest factors of this is just the flexibility of their time and having less work stress. You do have chores with robots. They're not a magic bullet where you can just install them and walk away. The difference is, if you have, say, 2 hours of work to do in the morning with 4 robots, it doesn't matter if you've got a really busy day, so you go out at 4 in the morning and knock that off and get it done. Or if, maybe you had a cow calving at midnight or something, so you're a little tired and you go out at 6 or 7. As long as the job gets done, there's a lot more flexibility. So with that, you can use that time to focus on other things, like maybe not having to drop people off of your crop crew, and doing a better job with your crops, which is going to lead to higher forage quality, decreased grain costs, healthier cows, more productive cows. Or maybe you just have some friends going out to dinner, or your kid's got a ball game and you actually get to go see that, where you might not have in the past. So just to put some very rough numbers down, I did some comparisons. So I looked at somebody milking, 240 or so cows. And if they were putting in a retrofit, so you'd be using the existing parlor with no new purchase on the parlor side at 16 hours per day and $15 per hour, that comes out to about $87,600. If you add, just a rough estimate of $5,000 per year in operating costs for that parlor, which is actually probably a little low, that would come to $92,600. And that's not factoring in housing or wage inflation, workers' comp, or anything like that. So let's say that farm is making 80 pounds of milk at $20 per 100 weight, it's 1.4 million in income. Now, if we move that same farm and we retrofit 4 robots on that barn, the installation cost, not counting construction, is going to be somewhere around $860,000. So rough numbers, with a 10% down payment on the loan for that $860,000 would come out to about $136,000 a year for 7 years. I even bumped up the wages to $18 because you may need fewer people, but you can trim off the lower quality workers on the farm and maybe pay the people that you really trust a little more. So I bumped up $3 an hour for that. You can get your milking chores as far as daily maintenance, cleaning, fetch cows that aren't coming in on their own, done in about 3 hours per day, which that ends up at $19,700. If you're staying on top of your daily management, doing some of the work yourself, chemicals, consumables included, we can be around $10,000 per robot per year. So with 4 robots, that would be $40,000 per year, which gives us $166,000. So let's say even in retrofits, 2X herds, we often see 10 to 12 pounds a cow, but obviously the nutrition has to be right. Things have to go correctly. The feed quality has to be right. So if we make it a 5-pound increase at $20 per 100 compared to the 80 pounds in the parlor assessment, we get a little under 1.5 million in milk income. So if we put that together, the annual cost during the 7 years where you're paying off the loan puts the parlor ahead by $73,000 a year. Now at 5 pounds of milk, we've got an increase of $87,600 with the robots. At 10 pounds of milk, we have $175,000 increase in milk income. So if we subtract the $73,000 higher cost of operating the robots during the year, we're still ahead by $14,000 at 5 pounds in those first 7 years. And of course, when the payment comes off, that's 136,000 a year. That makes a big difference. And what we've seen now that we have robots that are 12 to 14 plus years old, we really don't see massive increases in maintenance costs on these. As long as the farmer's doing a good job, and working with us on the quarterly service as well. Of course, at the 10 pounds, now on those 240 cows, right off the bat, even with the payment, you're at 101,000 a year. So, you add back in the 136, even if the maintenance was a little higher, there's some pretty significant increases here. And that's not counting some of the things we see where we often see more longevity. Some farms that operate large parlor systems and then have a separate robot facility have seen upwards of a 10 to 15% drop in cull rate, where cows are not being moved around 2 to 3 times a day to the parlor. There's fewer injuries. So there's good value there. Being able to detect health issues sooner and prevent major health issues and milk loss. There's certainly dollars there. So I was just making this very basic just to try and show some numbers on the payback. So if you break that down, at the 5 pounds while still paying the loan, it's about $59 per cow per year, or 20 cents per hundredweight. If we get 10 pounds, that bumps up to 400 plus per cow and $1.45 per hundredweight. So again, if we, once that loan's paid off, those numbers are gonna make a big jump in the positive. And then even with the loan, that's a fixed cost for 7 years, where labor is only going up, and labor security is up in the air right now as far as availability. On the robot side, we typically see about a 7-year average payback. The vector side actually is often faster, with about a 5-year average payback. So if we look at milking 300 cows, with a tractor and a mixer, compared to replacing the mixer with the 2 feeding robot vector system, we'd be somewhere around 330,000, not counting construction, which would be around 57,000 plus a year. And we'd be about an hour a day. Again, I put the higher rate here for feeders, tend to be a higher paid job than milkers. So that'd be 6,500 a year. The entire system's electric. So at 20 cents per kilowatt hour, we would end up being around $290 a year, and we'd be probably somewhere around 7,500 for maintenance costs. And this gives us 72,000 per year for the vector system for an annual operating cost. And again, this would probably be a 7-year loan. So after 7 years, that would be done. And we still don't see a large increase in maintenance as they get some age on them. Many of the farms that we've put vectors in have actually seen a 5-pound increase due to the frequent fresh feeding and always being fresh feed available. But 300 cows at 85 pounds is little over 1.8 million in annual income. Now with the tractor, we have no purchase if we're using existing equipment, so there's no loan. Feeding labor at 3 hours per day versus 1 hour a day, about 19,000. Fuel at $4 a gallon, which is actually 5 now, but at 4 is 43.80. And then there's going to be 20,000 plus in refusals per year. And with the vector system, because there's such a small amount fed, the cows are essentially almost eating it clean as it's getting new feed out. We basically have no refusals. So even if we're feeding refusals to heifers, there's still a value there, and it allows us to feed heifers diets programmed for them that typically aren't as expensive as cow diets. One of our customers actually said the lack of refusals alone was going to pay for the system for him within that average 5 years. But anyway, this gives us a $46,000 per year cost of operation for just keeping a tractor mixer wagon going as is. Now, if we do that at 82 pounds of milk, we're at 1.8 million per year income. So if we factor in the labor savings, the fuel savings, and with the loan payment, we're still a little bit behind for the first 7 years, with an advantage of the existing system at 26,000 a year. We add in the milk 3 pounds of milk. That bumps us up to 65,000 in favor of the vector. If we subtract that, we get almost $40,000 on 300 milk cows per year, or $130 per cow and 42 cents per hundredweight. And again, once the loan is paid off, those numbers will go up significantly. So anyways, anybody have any questions yet? So along those lines, with the time you save, maybe you can start a new enterprise and grow marshmallows. So thank you very much. And I have my email and phone number. If anybody wants to contact me, I'd be happy to go over more detailed numbers with everybody, specifically to any person's farm. And I also have a spreadsheet for some of the spreadsheets for some of the equipment we have. I'd be happy to go in detail if anybody wants to get a hold of me for their own farm. So with that, thank you very much, and I'm open to any questions.
Thanks, Chris. That was great. I know we have one question in the chat, and that was from Sarah, and she's wondering about using the manure collectors in sand bedded barns.
Yep, no, that's an excellent question. So we've got quite a few of them in sand. Just like anything with sand, it does take a little more management. Instead of maybe hosing them out once a week or once a month just to get any buildup in the tank to, keep the capacity from getting reduced. Originally, farms were having to hose them out maybe every 2 days, take like 10 minutes and hose the tank out every 2 days or so, depending upon the type of sand. Now we actually have a sand flush kit available that we can put in at the charger and dump station that actually helps run some water through and helps keep the sand from building up. So it doesn't completely eliminate the need to hose the sand out, but it keeps from packing. And, for example, maybe instead of every 2 days, maybe it's twice a week or so, and it's easier to get out. So those, we do have them in sand, and they actually clean very well in sand. Just take a little bit more cleaning than, with mattresses.
I've got a couple of
Oh,
questions.
and Sarah,
So
yes, we can add that to existing. It's collectors that are out there. We can add that sand kit even to some of the earlier ones.
awesome. So there's a lot of data that comes with the robot management system. How do you help farms determine what data is important for them to look at and what they should be focusing on, especially when they're coming from a system maybe that has limited data or no data in the case of maybe a tie stall farm?
Yeah, if the most you've ever used is a breeding wheel, it definitely could be overwhelming. And even with somebody that's been using PC Dart or Dairy Comp, with the milking information that's there, there's still way more data than even a parlor with meters. So that's a very good question because you could just get buried and lost in the data. And that's where we have Brianna on our team here in-house with our Lely Center New England team to work with farmers on focusing on the reports that will benefit them. And Lely itself not only has a strong technical team to back up our guys, but they also have a strong farm management support team with representatives that have previous careers in nutrition, veterinarians, things like that. So we have a lot of support to work with farms, and that's an ongoing thing. Like on my end, on the sales side, I work with farms initially to visit other robot farms, learn their interests and goals, see what might work for them, work on the barn designs. And then as we're getting close to starting up, then Brianna and the farm management side take over. And that goes on forever, whether it's a brand new farm with tons of questions, simply learning how to navigate the computer system at all, and what needs to be done to milk their cows 3 weeks from now or something, or somebody that's been milking for 10 years and is just looking at some reports and realizing that maybe their heifers aren't peaking as well as their mature cows, for example, or something smaller. Maybe they'd like to just get a few more visits, or fresh cows need to peak a little higher, things like that. That's something that we have the length of time you have the robots that work with us.
That's great. More along that line, so we talked a little bit about box time and how that can impact the number of cows you can milk on a robot. So if you see cows that have high production that have these increasingly long box times, how do you then on the farm management side start advising producers, whether it's breeding or um, other levers that they can pull to look at how they're managing the herd to really be an effective and efficient robot herd.
Mm-hmm. Yeah, it definitely makes a difference on the farm's current status and number of cows and free time, like I talked about, and their goals. So, if somebody has 50 cows per robot and they have 20% free time, then a cow that takes 10, 12 minutes doesn't really matter because there's still a lot of time in the system. But if somebody's already running on like 8%, like that screenshot I had, they're already full. So then it kind of comes down to looking at some numbers and looking at that cow and figuring out if, are you going to do better having two cows in her place? And, and as far as the future, working with genetic companies now that they're starting to have these, quote, robot ready cows available, they're starting to factor in some of those things as far as, teat placement and size for easier detachment and milk speed are becoming available in bull summaries. But we have a farm that moved out of a tie barn 10 years ago into a really nice sand bedded two robot freestall, and things were really clicking for them. They were at 103 pounds of milk on 120 cows, and they had a heifer come in and making 80 pounds of milk, but she was taking whatever 10 or 12 minutes per milking or something to do it. So they did, of course, there's nothing wrong with the animal, so she doesn't necessarily have to get beef. I think they sold her to a neighbor for dairy because they had zero room, with the production they had at the time for that heifer. And it was better off to let a couple other cows milk in her place for like the time she took. But it's still a good animal, so you could sell that animal to somebody in a parlor that's not watching those numbers as closely. The thing with the robots is not only do you see every single cow, every single milking and how long she takes, you see each quarter. So if you're milking in a parlor, especially with no meters, you might have this one quarter that takes 5 more minutes than every other quarter. And I know years ago you used to always mess around and put weights and things like that on them. And who knows if you actually got more than a pound or two of milk out of it. With the robot, you can see that 3/4 are done in 6 to 7 minutes and one's done in 11, but it also knows how much milk came out of each quarter. So you can see if that quarter only gave a couple extra pounds or if it gave 10 extra pounds in that time to help you make those decisions.
Sarah has another question. And so they have a lot of small farms in New Hampshire that have primarily family labor. The quality of life improvement is huge, but how often do those farms are those farms actually able to cash flow robots if they don't get the labor savings of a farm that maybe has more employees that are non-family?
Yeah, it is a little trickier to run the numbers on a small farm when you're not just simply taking a check you used to write to two milkers and now you're putting it towards a robot payment instead. So there's a couple options there. I mean, it comes down some, if a farm is already in heavy debt, it's admittedly difficult sometimes for a small farm to purchase robots until they knock some of that down. We do have options. We now have certified used robots. Previous A4 models have gone back to the factory, been cleaned up with dry ice, completely gone through, all wear parts replaced. Any parts that were an older style that have been improved can be, are updated. So we do have some options there as far as getting smaller farms started on robots. As much as the A5 is a spectacular robot and has some advantages over an A4, there's nothing wrong with an A4. The A4s we installed in 2012 still run perfectly fine, and actually, to be honest, run better now than they did when they were first sold because of the software and other improvements and just the knowledge people have now. So it's almost like getting a brand new A4 from the factory to buy that used one. So that we would just have to work with people on an individual basis.
Great. One more question. This one's about foot baths. So, what is
Hmm.
the best strategy to make them effective, but also keep cows from going through them too many times in a robot facility?
Yeah, that is a good question. I don't know if I've ever 100% come up with the answer. However, early on, people would just pour a foot bath right at the exit of the robot, which I don't think is necessarily the best idea because every single cow that goes through, even on days you're not using the robot, has to go through there and it gets full of manure and their feet get dirty. It's hard to keep clean. It's hard to clean. And then also, it can make new heifers and other animals balk and not exit quickly. Another option that some people did was put it beyond the far end of the pen, against like the farthest crossover. And then they just can walk the whole herd through a few times a week. But you still have to manually move all the cows then, which is one of the things we're trying to eliminate. So actually what I came up with quite a while ago that we've been using on most of our farms is we've been using one-way finger gates where cows walk through the gates into the robot area, but it's not a guided flow system. They still can go wherever they want. They don't have to go through a robot or a selection gate to determine if they're allowed to eat or not. All those finger gates do is make it so they exit through a footpath that is, in the vicinity of robots, but not right tight to the robots, like maybe 16, 20 feet away from the robots. So there's still plenty of room for cow flow around the robots and still allowing the cows to do what they want. And yet, having the cows automatically walk through a footpath versus having to be pushed through them. It is something that definitely has to be considered. When I first started this job, a farm had just retrofitted robots and hadn't come up with an idea for a footpath yet. So that's where I first came up with this idea because he was starting to have heel warts already just a few months in. So in that case, for the retrofit, I just suggested cutting out one stall width right in front of the robots. We put the one-way gates in, he put the footpath, sacrificed the two stalls, the two, that were the head-to-head two stalls. But then from then on, he had an easy footpath to maintain where he could just drop those gates down on the days that he ran the footpath, and then the cows would exit through the footpath. And then I took that concept into the other designs I've drawn since then.
That's great. Thanks, Chris. Does anybody else have any other questions? Okay, thanks again, Chris, for joining us. Really great information to think about when you're considering implementing automation on the farm. So we hope that you'll join us next month. Next month, we're going to talk about maintaining milk quality and automated milking systems. So we'll be joined by Dr. John Penry from Aurora Dairies, and we'll examine the factors that influence milk quality in automated systems and share practical strategies for monitoring and improving outcomes. We'll talk about udder health management, milking system hygiene, troubleshooting common quality issues, and best practices for farms that are transitioning to or operating automated milking systems. So again, you can scan this QR link to register, or if you're attending today, you may already be registered. With that, we thank you for joining us today, and we hope that you will take our survey. You can scan this QR code here, and we hope to see you next month. Thanks so much.